But what precautions should be taken during sample preparation? Number one is that the samples should be kept in cold or cool during transportation. They may be air dried remotely from the lab at a maximum of 40 degrees or when moist. However, this is not a requirement unless the soil is very moist. They can be broken up where they have got clods and cords. They can be removed rocks by hand or by sieving. To retain a representative sample, the sealed sample is usually put in a polyethylene bag to ensure that the moisture is retained in case the moisture determination process is required. Also, the sample size reduction can be done via coning or quartering or rifer. These methods are not they are not very familiar in this case. However, you can look at them to understand how coning or quartering or refill is done. The laboratory preparation of the soil samples include traying or air drying them on trays at a maximum of 40 degrees and mixing the soil, rolling or grinding it. The remaining soil could be less than 2 millimeters fraction, can be air-tightened in a plastic bag if requirements that do not concerning moisture are required. The preparation of a soil sample after it has reached in the laboratory, some processes are required. One of the processes is drying, the other one is sieving, and the other one is grinding and mixing in case the soil is not so consistent. Lastly, some procedures will require the soil to be stored in paper cartons or polyethylene bags prior to analysis. Now, the third step after the soil has been prepared is what we call as extraction and analysis of the available nutrient using a specific laboratory technique. In this case, the various laboratory method depends on why you are sampling the soil. However, the most common extraction analysis or analysis of nutrients that are available are the analysis of nitrogen, and this is usually done using alkaline permanganate. The available or the extractable phosphorus can also be analyzed using sodium bicarbonate for neutral or alkaline soils and using the Blaise and Curtis extract for acidic soils. The available potassium or the extractable potassium can be removed from a soil sample using ammonium acetate solution. The microcations such as zinc, copper, manganese, and iron can also be extracted using diethylene triamine pentaacetic acid. The boron can be assayed using hot water, while the molybdenum can be assayed using the Griggs reagent. These are the common soil testing methods. Others include the soil pH and the electrical conductivity. This can be done either in the field or in the laboratory using the respective meters, that is, a pH meter or electrical conductivity. In our next class, we will look at the various protocols in testing the various aspects of soils. The extractable clay, as I have said, the extractable phosphorus, as I have said, can use the Blaise-Curtis method or the Osland phosphorus method based on whether the soil is acidic or basic. The organic carbon is usually analyzed using the Walker-Black combustion method, which we will be looking at in the next class. The extractable potassium, as we have mentioned, is analyzed using the ammonium acetate method. Here is a representation of some of the soils being extracted their nutrients at the laboratory level. After extracting the nutrients or analyzing them, the other most crucial aspect is analyzing what you have. What you have is interpreting what you have analyzed. And by interpretation, in the case of macronutrients, the nitrogen, phosphorus, and potassium, they can either be categorized as too low, medium, or high. For these categories, it means that if it is low, you need to add. If it is medium, it is at the right portion for a particular crop growth. If it is high, you need to reduce it by soil conditioning. For instance, for nitrogen to be categorized as low, it must be below 280 kilograms per hectare. For phosphorus, it must be 10 kilograms per hectare, while potassium is 108 kilograms per hectare. Sorry. For them to be very high, for nitrogen, it must be beyond 560 kilograms per hectare, while for phosphorus, it must be higher than 24.6 kilograms per hectare, and potassium beyond 280 degree, beyond 280 kilograms per hectare. Therefore, the ideal amount of nitrogen, phosphorus, and potassium that is required is that which is within this range. In other nutrients, this table provides a summary of the ways they can be extracted and the various levels in which they can be categorized as low or high or medium. For instance, the organic carbon can be assayed using the organic carbon extraction method and is considered to be low if it is below 0.5 or very high if it is beyond 0.75. The same case for all the others, the extractable, the sulfur, calcium, magnesium, zinc, and all the other macro and micronutrients. I would like you to be conversant with this table so that when you go out there and you are the one who is tasked to do the soil testing, you can know how much is considered to be low and how much is considered to be high and what soil conditioners you need to add and when you need to add them and at what levels. But just to do a recap of what we have learned today is that after a soil test is done, usually a nutrient supply map can be drawn for farms, for larger regions, or for larger countries. That is, depending on the scale in which soil testing has been done, a soil map can be drawn based on the results of how many nutrients, how much of the nutrients are available, or how much is required. Such maps could provide a general picture or what we are calling a representative picture of the soil fertility status of a farm, a region, or a country. It is the reason why we say that soils in a given country are fertile or infertile or they are deficient of a given macro or micronutrient. It is from these conclusions are made from a nutrient supply map. The extent to which soil fertility maps can be used, however, depends on a number of factors. One is the available nutrient management strategies. You realize that in developing countries or in areas that are arid and semi-arid, despite knowing that the soils are lacking of certain nutrients, they do not have the capacity or the nutrient management strategies to correct these nutrient deficiencies. Another one is it also depends on how representative the soil sampling was done. For instance, if within a given country where we said we can use the subsoiling sampling approach, this was not done due to cost limitations, then it means that the soil samples and the subsequent conclusions made on a soil nutrient supply map are not accurate. If they were accurate, then it means that the measures that would be taken, the nutrient corrective measures, management measures that are taken are also correct. Therefore, it is very crucial to do the soil sampling correctly